In this video, we'll generate the trendline and polynomial of hyperbolic secant. So array formula, hyperbolic secant of the x values from -2 to +2. And enter. And the same using the infinite product series. So this is big pi of 1 over 1 plus x squared over pi squared n minus 0.5 squared, where the value of n is from 1 to infinity. So our value of n starts from 1 up to infinity. 9 is good enough. Now we complete the array formula. So array formula, that is, we begin with this portion. So that is x divided by pi, the quantity pi, times the quantity n minus 0.5. And this is the entire quantity squared raised to the power 2. And we complete the array formula. So this will be, we factor in 1 plus. So we complete the denominator. That is 1 plus. Then the numerator, which is 1. So that will be the quantity 1 over. Now we complete the product, infinite product series. So product from this part to 9. And drag this downwards. And chart this, insert chart. And we use scatter chart. Row 1 is header, column is label. And for the series, use the trend line, the type polynomial, the degree 8. And for the label, use the equation. Let's try 10 if that works. No, it doesn't work. So 8 will do. Here's our trend line and polynomial. You will notice the trend lines are almost collinear. And the polynomial is almost the same. So 1, 0x, 0.496 x squared, 0.4 minus 0.485. So there's a difference. 0x cubed, 0.184 x to the 4th, 0.179 x to the 4th. 0x to the 5th, minus 0.0441 x to the 6th, 0.0429 x to the 6th. 0x to the 7th, 4.43 times 10 to the minus 3, 4.31 times 10 to the minus 3. There's a slight error. That's because our value of n is from 1 to 9. If we increase that to higher value, like infinity, this error will be reduced and the line will be exactly collinear. This completes the use of product function to generate the hyperbolic secant.